Here is another example of writing a function as power series. This is a little different. You see the function is x by 1 plus 4x whole square. I don't know where to start on the whole thing here, but I do know a little bit about 1 by 1 plus 4x, which can be written as 1 by 1 minus negative 4x. Two negatives make it positive. And now you can compare with our 1 by 1 minus x is n from 0 to infinity x power n thing, where absolute value of x is less than 1, convergent for that. Okay, we know that. So in place of x, we have negative 4x. So this can be expanded as n from 0 to infinity using this negative 4x power n instead. Okay, let's simplify that. N from 0 to infinity, negative 1 power n 4 power n times x power n. Now, I want to have the square in the denominator, okay? We right now have only 1 by 1 plus 4x is equal to this function. We know a little bit that if we have, say, derivative of 1 by x, that would be negative 1 by x square, right? So a method to make the denominator square by without squaring it is differentiate. So I'm going to use that strategy. I'm going to differentiate both sides. Okay, let's do that. So the derivative of 1 by 1 plus 4x would be negative 1 by 1 plus 4x whole square times 4 is equal to, here we need to differentiate this series. That means this derivative can go inside, and only thing we need to derivate inside is x to the power n. Everything else is just a constant. And from 0 to infinity, negative 1 to the power n is constant. 4 to the power n is constant. What is the derivative of x to the power n? N times x to the power n minus 1, power rule, right? So we have our most of the function. We want to figure out x by that. So we want to multiply both sides with the x. So we can get the actual function. Let's see what we get. 4x with a negative sign by 1 plus 4x whole square is equal to, this x will multiply inside, and from 0 to infinity, negative 1 power n 4 power n times n. But when this x multiplies with x to the power n minus 1, it will automatically become x, because x to the power is 1 and n minus 1 powers add. This will become n. We are almost done. We have almost the same function, but this negative 4 is extra. So we are going to divide both sides by negative 4. When we do that, we are only going to be left with this on the left hand side. And when I divide the right hand side with negative, 1 power of negative will go down, 4's power will go down, times n times x power n. So you see, this is your actual function. So we can say f of x is equal to this, is equal to this as a power series, and this converges if, where, how did we know when does it converge? When we started with this, when absolute value of 4x is less than 1, or we can say absolute value of x times 4 is less than 1, or we can say absolute value of x is less than 1 by 4. So this converges if absolute value of x is less than 1 by 4. Therefore, radius of convergence is equal to 1 by 4. So answer to the series is this expression, and the radius of convergence is 1 by 4.